أعزائي الطلبة طلبة الثانوية العامة لغات وتجريبي، السلام عليكم ورحمة الله وبركاته. أهلا بكم في درس جديد من دروس الديفرنشيشن. بنكمل النهاردة مع بعض exercise 1-3 on derivative of higher functions or higher derivatives of a function. Now we will start from question 10. If y equals 3 cosine 2x plus 1, prove that d2y by dx squared plus 4y equals 0. So first we will calculate the first derivative dy dx, or you can say y dash. The derivative of cosine 2x plus 1 is negative sine 2x plus 1. Multiplying the derivative of the angle, the derivative of 2x is 2. 2 multiplied 3 equals 6. So y dash equals negative 6 sine 2x plus 1. Don't forget that the derivative of 1 is 0. So the derivative of the angle equals 2. 2 multiplied 3 equals 6. Negative here because the derivative of cosine is negative sine. Then we calculate y double dash, the second derivative. It is equal derivative of sine 2x plus 1 is cosine 2x plus 1. Multiplying the derivative of the angle. The angle here is the same, 2x plus 1. The derivative of 2x plus 1 is 2. 2 multiply negative 6 is negative 12. So y double dash equals negative 12 cosine 2x plus 1. Now, left hand side here, left hand side is d2y by dx squared plus 4y. We will calculate it and we will see. d2y by dx squared plus 4y equals. What is the value of d2y by dx squared? It is negative 12 cosine 2x plus 1. We write it. Plus 4y. Plus 4 by y. But y equals 3 cosine 2x plus 1. And we write 4 multiply 3 cosine 2x plus 1. And we simplify it. Negative cosine 2x plus 1 here. 4 multiplied 3 is 12 cosine 2x plus 1. And the answer will be 0. Negative 12 plus 12 equals 0. Equals right hand side, and this is the required. Number 11. Question number 11. If xy equals sine x cosine x, then prove that x d2y by dx squared plus 2 dy by dx plus 4xy equals 0. First of all, we must notice that we have sine x cosine x, and we know that sine 2x equals 2 sine x cosine x. So we will multiply both sides by 2 to get 2 sine x cosine x as follows. So we write multiplying both sides by 2. Then we have 2xy equals 2 sine x cosine x, because 2 sine x cosine x equals sine 2x. So this is the simplest form to right hand side. It will be sine 2x. Then we will start differentiation. We have here 2xy. We have xy, it is two function. So what's the derivative of the product of two functions? We write the first derivative, the second. It will be xy dash plus y equals the derivative of right hand side. Derivative of sine 2x is 2 cosine 2x. The derivative of sine 2x is cosine 2x, multiplying the derivative of the angle. Derivative of 2x is 2. And then we divide both sides by 2. We get xy dash plus y equals cosine 2x. xy dash plus y equals cosine 2x. Then we will make a differentiation to both sides once more, because we need d2y by dx squared is the second derivative in the required here. So we must make a derivative again for second time. So we have the first derivative, the second, it will be xy double dash plus y dash multiply derivative, the first derivative of x is 1, so we have y dash plus the derivative of y is y dash equals, what is the derivative of cosine 2x? It is negative 2 sine 2x. And we simplify. We have y dash plus y dash, it will be 2y dash. So the left hand side will be x y double dash plus 2y dash minus will be plus. We will remove it from right hand side to left hand side, so it will be 2 sine 2x, it's equal 0. It is the same required, x y double dash is d2y by dx squared plus 2 dy dx plus 2 sine 2x, and we write xy double dash plus 2y dash plus 2 multiply 2xy equals 0. It means x multiply d2y by dx squared plus 2 dy by dx plus 4xy equals 0. 2 multiply 2 equals 0. Question 12. If y equals x sine x, prove that x d3y by d x power 3 plus x dy by dx plus 2y equals 0. So we'll make the first derivative. We have y equals x sine y. We have the product of two functions, x multiply sine x. So y dash equals the first derivative, the second derivative, second function, the derivative of sine x is cosine x, plus the second function multiply derivative the first, multiply 1. So y dash equals x cosine x plus sine x, and we make a differentiation for second time because we need to calculate d3y, third derivative, y triple dash. So y double dash equals, when we make a differentiation here, we have the product of two functions. So we have the derivative of x cosine x is negative x sine x, plus the second derivative, the first, will be cosine x, and the derivative of sine x is cosine x. So cosine x plus cosine x equals 2 cosine x. This is y double dash. Then we make the derivative for third time. Y triple dash equals negative x cosine x minus sine x, and the derivative of 2 cosine x is negative 2 sine x. And we simplify it. We have negative sine x minus 2 sine x equals negative 3 sine x. So the right hand side will be negative x cosine x minus 3 sine x. Left hand side, it is x y triple dash plus x y dash plus 2y. We substitute from these results in the left hand side. So first we write x multiply y triple dash. Here we have y triple dash multiplying x, you will get negative x square cosine x minus 3x sine x here, plus xy dash. Where is y dash? Here is y dash. So we multiply it by x. So we will get x square cosine x plus x sine x Again, when you multiply y dash by x, what you get? X squared cosine x plus x sine x here, plus 2y. 2y. We have 2 here, but y equals x sine x here. So 2y, it means 2x sine x. And we can cancel, simplify these sides. We have negative x squared cosine x plus x squared cosine x equals 0, and negative 3x sine x plus, here is we have positive 3 sine x, so the result equals 0 according to the required equals right hand side. If y equals sec x, prove that y d2y by dx squared plus dy dx all squared equals y squared multiply 3y squared minus 2. First we will get the first derivative. What is the first derivative? The derivative of sec x is sec x tan x. It's y dash. Then we calculate y double dash. We have two functions. First function is sec x, multiply the derivative of the second, it's sec squared, plus the second multiply the derivative of the first. The derivative of first function is sec x tan x. And we complete. Sec x multiply sec square x equals sec power 3x. Tan x multiply tan x, it will be tan square x. So y double dash equals sec power 3x plus sec x dot tan square x. Here left hand side equals y double dash plus y dash squared. Y double dash plus y dash squared. But y dash equals sec power 3x plus sec x tan x squared. So when we multiply y by y double dash, we will get, don't forget that the value of y is sec x. We will get sec power 4x plus sec square x tan square x. So this side till now equals y multiply y double dash. Y multiply double dash as y equals sec x plus y dash squared. Y dash is sec x tan x, so y dash squared equals sec square tan square as follow. So it's plus sec square dot tan square. And we'll simplify this. Sec power 4 is sec power 4. Sec square tan square plus sec square tan square equals to sec square tan square. Okay? Here we can take sec square as a common factor. Here we take, after you take sec square as a common factor, what you will get inside the bracket? You divide sec power 4x divide sec square x equals sec square x. 2 sec square x tan square x, divide the common factor, you will get 2 tan square x. And we substitute sec square y square, sec square y square, 2 tan square x. You know that tan square x equals sec minus 1, equals sec square minus 1. Tan square x equals sec square minus 1. So 2 tan square x equals 2 sec square x minus 2. And this is required. Why? Because sec square is y. So when we said 2 sec square, we can substitute it by 2y square. So y square plus 2y square equals 3y square minus 2. And this is the required itself. If dy dx equals 2x minus 3, dz dx equals x square minus 1, find d2y by dx squared at x equal 2. Again, we have dy dx equals 2x minus 3, and dz dx equals x square minus 3. The required here is d2y by dx by dz square. So first we will calculate dy dz, then we make the differentiation once more. So first we calculate dy dz from here. How you get dy dz? By division. So by dividing 2x minus 3 over x square minus 1, you will get dy dz as follows. Here we have the problem again. Then dy dz equals dy dx divide dz dx. So we write 2x minus 3 over x square minus 1. Then we make the differentiation again. Don't forget, we make the differentiation with respect to z. Again, we have dy dz equals 2x minus 3 over x square minus 1. We'll make a differentiation again with respect to z to get d2y by dz squared. And we make a differentiation again with respect to z to this fraction. We write the denominator multiply derivative of numerator. The derivative of numerator will be 2 minus the numerator multiply derivative of denominator. Derivative of x square minus 1 with respect to z equals 2x multiply dx dz over the denominator squared, and we write it. Now we simplify. So the simplest form of the numerator is negative 2x squared plus 6x minus 2 over x squared minus 1 multiply dx dz, dx by dz. We have here dz by dx equals x squared minus 1. So dx dz equals 1 over x squared minus 1. And then when x equals 2, you substitute every x equals 2. When you substitute x equal 2, you will get 4. 4 multiply negative 2, negative 8. 6 by 2, it's 12 minus 2 over, substitute x equal 2, it will be 4 minus 1. 3 square equals 9. Multiply 1 over 3. And the final result will be 2 over 27. So d2y by dz squared equals 2 over 27. 15. If x equals 3n square and y equals n power 3 plus 2, find d2y by dx squared at n equals 4. First, we will calculate dy dx. How we get dy dx? Dy dx equals dy dn divide dx dn. So first we calculate dx dn equals 6n. The derivative of negative 1 is 0. dy dn equals 3n squared. Okay, and dy dx, it is the division of dy dn divide dx dn here, equals 3n square over 6n, which equal n over 2. Simplest form of this is n over 2. But the required here is to find d2y by dx squared. So we'll make a differentiation again with respect to x. So d2y by dx squared equals the derivative of n over 2 with respect to x equals half dn dx. dn dx. What is the value of dn dx? It is 1 over 6n, because dx dn equals 6n. So the reciprocal of this will be 1 over 6n. So when n equals 4, the result will be 1 over 2 multiply 1 over 24, which equal 1 over 48. Number 16, if x equals z plus 1 over z minus 1 and y equals z minus 1 over z plus 1, find dy dx at z equals 2. Again, we will find dx dz equals negative 2 over z minus 1 squared. It is the simplest form. And we find dy dz equals 2 over z plus 1 all squared. Okay, try to do it yourself. And then dy dz equals the division dy dx dy dz divide dx dz. You will get negative z minus 1 all square over z plus 1 all square. When x equal 2, the result will be negative 1 over 9. It's very easy. If x equals 6z and root y equals tan z, prove that d2y by dx squared equals 2. So by differentiate both sides here with respect to z, what we get? dx dz equals sec tan. The derivative of sec is sec tan, the same angle z. And we make a differentiation here with respect to z. The derivative of the root y is 1 over 2 root y. But we make a differentiation with respect to z, so you must multiply by dy dz equals the differentiation of right hand side, tan z equals 6 square z. And we calculate 1 over 2 tan z dot dy dz equals 6 square z. We have here root y equals tan z. So you can substitute root y from the given equals tan z. So we write 1 over 2 tan z. Instead of root y, we write, yes, tan z dot dy dz equals 6 square z. So we can deduce that dy dz equals 6 square z divide this fraction, divide 1 over 2 tan z. So dy by dz equals 2, 6 square z tan z. dy dx equals dy dz divide dx dz. Chain rule equals, what is the value of dy dz? dy dz equals 2 6 square tan, 2 6 square tan over dx dz. dx dz equals sec tan z, of course. And after simplify, tan z with tan z, 6 square over sec equals 6z. Multiply 2. So dy by dx equals 2 sec z. d2y by dx squared equals d dx 2 sec z. 2 sec z, it is dy by dx. The second derivative will be d dx of 2 sec z. So we'll make a differentiation of 2 sec z with respect to x. The derivative of sec z is sec tan. Sec tan. It will be 2 sec z tan z multiply dz dx. dz dx. We have dx dz. dx dz equals sec tan. So dz dx, it is the reciprocal. It will be 1 over sec z tan z. 1 over sec z tan z. After you cancel numerator with denominator, you will get 2. And this is right hand side. I hope you understand everything. Thank you and goodbye.